So your ultimate goal in a course like this, in a physics course and any engineering courses to follow, is to be able to work a problem to its answer. To do that, you would read a problem, try to understand what it is asking for, identify the variables and the possible formula that you would use to solve for the answer, and mathematically solve for the unknown. Showing all your steps along the way, starting from the algebraic formula to begin with, and making the proper calculations to an answer. So more important than the answer itself is this solution, this whole process of showing all of your work. Now, traditionally, when you take a physics course or engineering course like this, you would go to class and get some theory and get the concepts and formula, and you would be assigned some problems, and you absolutely would get no examples, and then you'd be told to work on it, and it took a lot of time. This is the way I learned physics, and it's the way I learned a lot of engineering. The professors in the books had no examples. They would just give you problems and tell you to work on them, and frankly, it was almost as if they didn't really want you to learn. This information was so valuable to them that they wanted to keep it all to themselves. Well, I want you to learn, and here's my method. Yes, we got the theory, the concepts and the formula. You should definitely know those. But we have the problems, and all of them are worked out as examples. So all the problems in the problem sets have solutions that you can see. So you could watch those solutions. First of all, you should try to work a problem, but don't spend hours on it going nowhere. If you get stuck, watch the solution. Watch the video solution, and then after you watch that and understand it, close the solution, and then reread and rework the problem. If you can't get through the problem, go watch the video again. Watch the part where you need to understand more, close the video, and start over. Reread and rework the problem yourself, doing every pen stroke yourself. And then try your hand at a new problem. See if you can work the next problem, because the problem sets are designed to be rather similar from problem to problem in many cases. So try your hand at the next problem and see if you can do it. And if you can't, look at the solution for that, and then close that solution, reread it, and rework it to the point where you can do all the work yourself to an answer. Here's how it might work out in practice. We're at the Content tab, and we go into the chapters. And let's just go into one of these chapters. Let's say chapter 4 here. And here's what I have here. I have some lectures where I'm going to be given the material and the formula. I have a Central 10 homework assignment here, which I'll talk about in a moment. And then I have the problem set on education videos and a PDF file, the problem set in here as well. And this is so important that I have redundant problem set, the same problem set on YouTube video, just in case the education videos don't work for you at some point. So we have this redundant YouTube videos available as well. But if we go in here on the problem set, here I have a problem set PDF. Let's click on that. And let's take a look at a problem here. Let's go back. All right, let's look at problem number 2. Your baseball's hit at ground level, blah, blah, blah. So I'm looking at this problem, and let's say I can't figure out how high it is when it gets to the fence. So let's go back, and I'll look at the solution for problem 4.2. So on the solution, you have me working it out just like you would work it out, step by step, starting from variables here, and then an algebraic equation with no numbers in them to begin with. Always do that. And then putting in my known values and then solving for an unknown. In this case, we have 2 directions, so we have to worry about the x direction and the y direction. And then we come up with an answer. Here our answer is actually 13.5 meters when it reaches the fence. We got some extraneous information in the x direction here. But there's my solution, and this one, well, it was 6 minutes long. Most of the solution videos are probably 2 to 5 minutes. But I would try to understand, and you hear me talking in these videos when they're going on step by step, try and understand what I did, and then try to recreate it. Reread the problem, close the video solution, and see if you can work it out the same way. And if you can't, if you get stuck, watch the solution again. But get to the point where you can do all this work yourself. So basically what we're striving for here in the problem set videos, first of all, is efficiency. We want you to learn the problem and see a solution and try to understand how you go about that solution without you wasting a whole bunch of time. I mean, you can look at a problem first and then look at the videos. And then your next step is proficiency. You want to be able to work out all the problems yourself, from the beginning algebraic formula to the final answer, showing all the steps and all the work along the way. So this is the most efficient way to learn fast and completely in this subject matter. And then when you see a new problem with this kind of proficiency, you'll be able to approach it and work it out on your own as well. So that is our goal. So what about these essential 10? Well, honestly, for full mastery of the physics, yes, you want to watch the lectures, you want to read the book, you want to look at the notes, you want to study all that. You don't want to spend all your time on that though. You want to spend most of your time working problems. And officially, you are assigned all of the problems in the problem set. So I want you to work all of the problems. Each successive problem will require less time once you get more proficient. And so that is where you want to be. Sometimes we don't have enough time, and I understand that. So each chapter has what I call an essential 10 problem list. That is what I've picked out to be the 10 most representative problems of the material in that chapter. So it covers the basic concepts that will be found and quizzed upon on the quizzes and the exams. When I give a quiz and an exam, I'm not going to look for the most obscure problem and try to quiz you on that just to be, hard on you. I'm going to look for the ones that actually represent the most important material in that chapter, and that basically will be the basic concepts. So in the very least, you should know these essential 10 problems. You should work those out probably first, and then start looking at problems that are similar to those, and then kind of develop your mastery of the problem set in that way. And that way you again will be as very efficient in terms of how you are spending your time working problems.